This is for students of class 12, Statistics Part 1, Chapter 1, Index Numbers. Now, obviously this is a topic which is completely new to you. Last year you studied different kinds of methods of obtaining mean, median, mode and standard deviation. That's a different part of statistics, and now we come to commercial statistics, where all this is actually very useful, especially for people like economic ministers, finance ministers, that is, all those people who are actually practically applying day-to-day knowledge in variation in prices and all that. That is where index numbers become very important. Alright, so let's see what index numbers are. First of all, the percentage change in the value of a variable in the current year compared to its value in the base year is called its index number. The important word here is percentage change. Like for example, your own performance. Your performance in 11th standard, compare it, your performance in 11th, you compare it with your performance in 10th standard. The percentage change in your performance in 11th compared to your 10th standard performance, that is also a kind of index number. So here, this is an index number. What changes are taking place? You see, in economics, especially in commerce, we are dealing with price and quantity. So that's why for us, price and quantity becomes important. But we want a particular kind of change. Percentage change gives you an exact idea of how much change has taken place. That change can be positive or it can be negative also. Sometimes the change can be downwards, where the price goes on decreasing, a negative trend with that. Sometimes it may be a positive trend. It depends upon what item is selected. We'll discuss that just now. Once again, the percentage change in the value of a variable in the current year compared to its value in the base year is called its index number. Alright. Now, when we talk about a variable, you see, compare here, look at this, the word variable. Percentage change and variable. What is this variable? Well, in commerce and in economics, the variable is different. When we study mathematics, the variable of x and y, that's speed, velocity and all that. But in commerce, of course, the variable is completely different. In commerce, the variable can be price, it can be quantity, it can be demand, supply or production. These are all different variables. And the item that we choose, it may be wheat, sugar, it can be bajra, or it can be tea, coffee, whatever item we choose. And that item, its variable can be price, the variable of wheat may be price, the variable of wheat may be quantity. We may be discussing the change in demand of wheat in one particular year compared to its value in the previous year or in the last 10 years. Choosing a base year is important. When you choose a base year, it gives you a percentage change. But different people may choose different base year, and therefore the percentage change may vary. So choosing a base year is vitally important. Look at this, for example, supply, demand and production. Again, production is a very important aspect of economy. If you compare the production in 2020 with 2010 or with 1975, the values are going to be different, obviously. That's why in economics you see the base year, selection of base year is vitally important. So percentage change in any variable, these are all variables, and this is an item, sugar, wheat, coffee, tea and so on. So its value in the current year, compare its value in the base year, and that percentage change will give you its index number. Alright, now change can be measured in two ways. All that percentage change, although it's a percentage change, but it can be measured in two different ways. Absolute measure is obtained by simply the difference, plus minus, minus plus difference, you see, between its value in the previous year, value in the 2010, its value in 2009, minus it and you get difference. That is absolute measure. Relative measure is a ratio, you divide. Okay, divide the value of the variable price, for example, in the current year with its value in the previous year or with its value in say 2000. So this is a ratio, this is a difference. There are two ways to measure change: absolute measure or difference, and relative measure or ratio. This relative measure is also called relative change because you are comparing it with something, and therefore it's called relative change. Example, relative change in price. When we discuss relative change in price, it is called price index number. And when we discuss relative change in quantity, it's called quantity index number. So you can have different index numbers for different items chosen, and also for different values or values of the variable. So relative change in price is called price index number. Relative change in quantity is called quantity index number. Relative change in production would be called quantity or production index number. Relative change in demand index number, and so on. We will be mostly discussing the first one. Alright, now general index number. What is general index number? General index number is the average percentage change of more than one item. Supposing in wherever you choose 4 or 5 different items. Let us say wheat, okay, rice, sugar, tea, these 4 major items. If you choose these 4 major items and calculate individual changes in price, individual price index number, and then add it up and divide it by 4, you get general index number. So that's for average percentage change of more than one item will give you general index number of all those items. Example, general index number of wheat, rice, sugar, tea and coffee together. How many items are there? 1, 2, 3, 4 and 5. So you calculate the index number of each one, add it up, divide it by 5 and you get the general index number of all these food items. Look at here. When calculating index numbers, you need the base year. As I have said, base year is vitally important because comparison has to be made with something. You are comparing with the previous year. You are comparing with years before that. You are comparing with the last 10 years and so on. So base year is important. Now, the base year can be the previous year or it can be some fixed year. For example, the price of wheat from 2000 to 2010 is given. Now, the base year can be 2000 or the base year can be 2005. Any of the years, it depends. It can also be previous year. The previous year, 2009, that also can be the base year. It depends upon the question. The base year can be the previous year or some fixed year or the average value of some years. Supposing the question is given, take the base year as the average of the last 3 years. Then of course, you add all the values of the last 3 years, divide it by 3 and you get the base value or the base year value. When we do these problems, you will see how easy it is. 2 methods of calculating index numbers. Now there are 2 ways of doing it. Fixed base method and chain base method. The formula for both is the same. For fixed base method, index number I is equal to P1 upon P naught or P0. You can call it P0 also. P naught also means the same thing. So index number I is equal to P1 upon P0 into 100. I prefer to call it P0. If you prefer to call it P naught, that's fine. Chain base method also, index number I is equal to P1 upon P0 into 100. But what is different between them is this, P0. The value of P0 in the fixed base method is the value in the base year, whatever the base year may be. Whereas in the chain base method, the value of P0 is the value in the preceding year. The year before, preceding year. Okay, that is the only difference. Chain based method and fixed base method. The formula is the same. There is no difference whatsoever. Also remember that P1 upon P0 is called price relative. And therefore index number is percentage change. So if you multiply P1 upon P0 by 100, you get index number. In other words, index number is equal to price relative into 100 because P1 upon P0 is price relative. And when you multiply it by 100, you get percentage change. And that's why index number I is also price relative into 100. Then, if you want to calculate general index number of say 4 or 5 food items, then there will be a slight change. Index number I or general index number of so many food items would be sigma P1 upon P0 upon n into 100, where n is the number of items. For example, how many items are here? 1, 2, 3, 4 and 5. Then in this case, n would be 5. So n would be 5 multiplied by 100 because you want percentage change, and sigma P1 upon P0 will be the price relative of all the 5 items added together. Again, when we do an example, you see it's quite easy. Alright, now let's see one example here. Calculate the price index number of wheat from the following data. Calculate the price index number of wheat from the following data and take 2005 as the base year. So we've got fixed base method. We are going to solve this problem by the fixed base method because the base year is given. The base year is 2005. Alright, now what is the data given? Year and price per quintal per 100 grams, 100 kilograms. Price per 100 kilograms or quintal in rupees 2005, 2006, 2007, 2008 up to 2013. And the value, that is the price per 100 kilograms, price per quintal in each year. This is the price of wheat in 2005, 1650 rupees per every 100 kilograms. 2006, 2007, the price you can see, if you have a look at it, you can see the price generally tends to increase. It is generally increasing. That means there will be a percentage increase in the price. Now, here when you want to solve the problem, year is given, price per quintal in rupees is given. This price is the current year. For each one, P1, this is the value of P1 for each current year. And we are given the base year as 2005. So, index number I will be P1 upon P0 in 200, where P0 will be 1650 because the base year is given as 1650. So calculate that 2005 index number would be 1650 upon 1650. Obviously it is the base year. So the index number for the base year will always be 100 in the fixed base method. Into 100 is 100%. Calculate for different values. For example, see this, for 2009, 1810 divided by 1650 in the base year into 100, you get 109.70%. Similarly for the last year, 2013, 1950 rupees. 1950 divided by 1650, the base year into 100, and you get 118.18%, 18%. So thus you can see, if this is, what is the percentage increase? In the base year, it is 100%. Okay, and in 2013 it is 118.18%. See what I have written here. Thus the increase in price of wheat in 2013 as compared to 2005 is 118.18% minus 100%, and that gives you 18.18%. So this is what you get an idea of percentage increase in price of wheat from 2005 to 2013. The price of wheat has increased by almost 20%, which is 1/5, 20% increase. So, if you want to calculate the price index number, there are two ways of doing it. This is of course one way. This is the fixed base method, or you can have it in the chain based method. In the chain based method, this one, you see, it would be the same formula, but what would be different is P0. P0 will be the value in the preceding year. Now, suppose I want to do the same problem. Okay, if I want to do the same problem by the chain based method. Now if I want to do it by the chain based method, you can see there is just small change, one small change, and we might get slightly different values. Let's see what happens now if I do it by chain based method. Alright, the same problem but by chain based method. We have here, okay, from 2005, 2006, 2007, 2008, 2009, 2010, 2011, 2012, 2013. And price per quintal. Price per quintal. Quintal meaning 100 kilograms. The price is given in rupees. The price 1650, 1690, 1650, 1690, then you got 1730 and 1750, 1730, 1750, 1810, 1850, 1810, 1850, and then we got 1900, 1870, 1900, and finally 1950, 1950 rupees per quintal. Alright, now we choose fixed base method 2005 as the fixed base. But supposing you want to do the same thing by the chain based method, alright, then in this case it will be the same formula, P1 upon P0 into 100. Okay, but this is by the chain based method. Therefore P0, the value of P0 will change, because the value of P0 in this case is always the preceding year. So for example 1650, okay, if I take 1650, the value in the current year and the value in the previous year is there No, it's not there. So what do we do? In this case, we always take it as 100%. So this we take it as 100. For that, you can see here it is just 100% because 1650 upon 1650. But in this case, it is 100% simply because the preceding year is not there. Alright, now in this case, now P1 1690 upon 1650. The previous year is 1650 into 100. Similarly here, 1730 is the current year, 1730 upon 1690 into 100, and so on. In this case, last year 1950, the value is in the current year is 1950. The value in the previous year is 1900 into 100, and this will give you so much percentage. Now, in this case, in each case, it's easy to calculate the percentage. You can see, okay, you can cancel out 0, and you can, in this case, it would be 1730, 1750 upon 1730 into 100. Okay, then 1810 is the current year. The previous year is 1750 into 100. Okay, then 1850 is the current year. 1810 is the previous year into 100. Similarly, if you take 1870 is the current year upon 1850 previous year into 100, you get this. And finally 1900 upon 1870 into 100 is equal to this. So you get percentage change in each one. Okay, so you get percentage change. Now you can see it's very easy. All you need is a calculator and you can easily do this. But basically what I am trying to tell you is that both methods are easy, simply because they are basically the same. There is just one single change. In the fixed base method, value is in the base year, and in the change base method, the value P0 is value in the preceding year. This is the fixed base method because the value of P0 is fixed. Here, the value of P0 goes on changing. That's why it's called change based method. It is previous year, previous year, previous year, and therefore that's why it's called the change based method. Alright, now let's do one more example about supposing we have got, say, another one. Say we have got different food items. Okay, we have got different food items. The different food items are bread, eggs, I know some of you don't eat eggs, but in any case, ghee, milk, everyone drinks milk in the morning, milk, cheese, and butter. Okay, its unit is given. This is of course on page number 8, just in case you have the textbook open. Items are given: bread, eggs, ghee, milk, cheese, and butter. How many items? 1, 2, 3, 4, 5, and 6 items are there. And the units are given. In units are packet, dozens. This is given: bread is in packets, eggs are in dozens, ghee is in a tin, milk in liters, cheese in kilograms, and butter in kilograms. And then after that, we are given price per unit of the same item in 2 different years, 2014 and 2015. Now we want to find the general index number of all the items. So price in rupees in 2014 and price in rupees in 2015. Alright, so 2014 the price is 25, 30, 25 per packet, 30 per dozen, then we got 375 rupees per tin of ghee, 36 rupees, then 440, and finally butter is 265. And the price in 2015 is increased up to 28, 35, and then 380, 40, then 500, and then 300. Alright, now I want to find the general index number. So this is the previous year, 2015. I want to see the increase in price, that is the general index number of all these food items. So we take this as P0, and we take this as P1. Okay, this is your P1 and this is P0. So now first we can calculate what is called price relative. Price relative is P1 upon P0 for all the food items. So P1 is 28 upon 25 is equal to how much? 35 upon 30 is equal to then 380 upon 375 is equal to then 40 upon 36 and 500 upon 440 and finally 300 upon 265. Now these will give you the price relative. Okay, here you get the price relative for each item, and then here what we do is simply total it up, right? Total, and this is your sigma value of Py upon P0. Add up all this and you get this value. Now once you got this value, all you have to do is simply apply general index number. General index number of all the 6 food items. Remember here n is equal to 6. 1, 2, 3, 4, 5, 6. N is equal to 6. There are 6 food items. General index number of all the 6 food items would be sigma P1 upon P0 upon n into 100. Whatever the value is this, divided by 6 into 100, and you get general index number. Now obviously you can see it is very easy to calculate in each case how much the value of general index number you will get. Well, I am just making it easy for myself a little bit. 28 upon 25, 28 divided by 25 gives you 1.12, then 35 upon 30, 35 divided by 30 gives you 1.16 or 1.17. I'll take it as 1.17 up to 2 decimal places. 380 upon 375, 380 divided by 375 and gives you 1.01. Then 40 divided by 36, 40 divided by 36 is equal to 1.11, and then finally 500 upon 440, 500 divided by 440, you get 1.14 up to 2 decimal places, 1.14. Then 300 upon 265, 300 divided by 265 is equal to 1.13. Alright, so 1.12 plus 1.17 plus 1.01 plus 1.11 plus 1.14 plus 1.13 is equal to 6.68. This is 6.68. Now 6.68 multiplied by 100 gives you 668, and divide this by 6 gives you 111.33. That is 111.33. Remember, this is in percentage. So if the question is asked that what is the percentage increase in the general index number of these 6 items compared to the previous year, then it would be 111.33 minus 100 will give you 11.33 percentage increase in the price of these 6 items. Now tomorrow I'll send you other videos and we'll carry on with this, but for the time being, just make sure you review whatever I've taught you here, all the formulas and how easy it is to calculate, and if possible try exercise, the first exercise 1.1. they are similar to these two methods only, chain based method, fixed based method, chain based method, and then general index number of some food items. Exercise 1.1 is similar to these problems. Just try it out. After that I will do it on the board. Thank you. Have a nice day.